So in today's episode, we are going to go and work on trying to restrict our movement of our cube when it's in the maze to actually stay in the maze. So if you have been watching the first few episodes, I think it was the first one and maybe the second one, we started working on the movement of our, our cube to move around the maze. But what we found out is when we move around the maze, or when the cube is inside the maze and we try and move around it, even though we have put colliders on the cube and the walls itself, it still manages to go through the walls, so that was not what we want. So instead, we are going to go and fix that and try and get it working so that our cube is only allowed to move within the maze. So let's go and jump into it and get started, because it should, it's not extremely difficult, but you never know what's going to happen. So let's go and get started. So this is where we left off yesterday, or whenever that was. So let's go play the game quickly and just make sure we are still where we were. So here we have our game over here in the corner. We have our cube. If we go and move our cube backwards and then to the left, okay, and to the right, you can see that we can move within the maze. And then as soon as we go through that trigger, which is this green sphere over here, we get this message pop up saying we've reached the end of the maze within so many moves. But what we want to go and fix now is this issue that we have when we go and try and press forward when we've reached the end of the maze. You can see if we press it once, it kind of bounces back into the maze because it knows that there's a wall there and there's a collider on that wall, so it's not allowing you to go into that wall. So if there's another error, so if we go and press the up arrow where we are twice quickly, it kind of jumps out of the maze, and this is what we don't want. So this is what we are going to go and work on today. So what we have to do this, or at least this is a way that I have come up with. If anyone that's watching this knows like a more simpler way to do it, go ahead and comment down below and we might change it. But for now, what we're going to do is we are going to go and check whenever we, let's do this. So where are we? In here. First of all, let's do this. Zoom out. So where are we? There we are. So if we go over here quick and then kind of focus on this cube in the middle. So look here. So say this is where we are over here. So what we're going to do is when we go and move, say we are going to move backwards because we need to go this way. When we go and press the back button, which is going to be the down arrow, we are first going to go and check if there is anything in front of it. And if there isn't, then we will allow the cube to move into there. And then the same thing we're going to do for each side. If we go and move right, we're going to go and check if there's anything there. In this case, if we try to move right, it wouldn't allow us to move right because there is a wall over here. Same thing for this forward movement, and then the same thing for the left movement. So that's what we're going to start working on today, and we'll see how far we get with that. So let us go and get stuck into it. So in our cube script, everything I think is going to be done inside our cube script. So what we want to do this, we are going to use raycasts. So let me just bring up this. So let's go and do this. For now, we'll leave this how it is, and then we're going to go and bring our fixed update method. So let's go and say fixed update. And then in here, we're going to work on one side of the cube first. And for this, we will work on, let's say, the forward direction. So we need to have some sort of vector3 variable that will tell us which direction we're going in. So here, let's go and say vector3, and we'll call this forward. Then we will set this to be equal to our transform dot what is it called? Transform direction, and this is going to be vector3, I think, dot forward. So save that, and then what we're going to do after that is now we need to go and say, we'll put in an if statement and say if the if physics, because we're going to cast a array. So when, say this is our forward direction over here facing towards the top of the screen, when we go and press our up arrow, we are going to cast an array and see if there's anything in there. So when we do that, if the ray cast actually hits something, it means there's something there and you can't move it. For now, we won't put any restrictions on it. So for now, if there is anything in front of it or behind it or left or right of it, if it hits that, it's not going to move forward. So when eventually, if we reach our sphere here, you'll see later if we get it working, when we reach the unit before that, it won't actually go through it because it's registering that it's hitting something in the next unit. But later on, once we get this all working, we'll go and add some restrictions onto it and some layer masks to ignore certain objects and things. So where were we? So here we need to go and say physics.raycast, and then we need to say we're going to give it the transform position, because that is going to allow it to cast from the cube, because this is going to be attached to our cube script, so it's going to take the position of whatever the script is attached to, and then we are going to tell it which direction, and we created a forward direction up here, so all we're going to do is copy and paste that, and then what's left is we need to tell it what distance we want it to cast out to. So because I think it's going to be casting from the very center of the cube, we only really need 1 unit, because from the center of the cube is going to go 1 unit out, which means it'll go halfway into the next unit. So, and if there is something halfway into the next unit, it will register that there is something there and it won't allow you to move. So let's say if we cast that raycast and it brings back some sort of error, not some sort of error, but if it turns out to be true, then that means we will print a message in the console that will say there is a wall in front of you. So let's save that, and then why have I got this error here? Else we will say there is not a wall in front of you. So we'll save that, and now we should see, if we go and push this down here, we should see in our console that it's going to constantly print out. We'll fix that later by removing it from the update method, but you can see now that because we are going forward, it's printing out saying there is a wall in front of you, and if we move back 1, it's going to say there isn't a wall in front of you. So that's working nicely. And if we go all the way to the other side, you can see that here, if we scroll down, we won't reach the end, but it will say that there is a wall in front of you. So you can't really read this properly because it's constantly going, because it's in the update method. So that is pretty much useless to us, but you can see it's working, so that is great. So what we want to do here is we need to try and modify this so that we can reuse it for the other faces of the cube. So let us go and create another method here called private. We're going to return a boolean, so if we return true or false, it's going to determine whether we can move into the next unit position. So we'll say private boolean move cube. We'll name it move cube for now, and then we will change it later on. So in here we want to pass in a vector 3, and this is going to be called our direction, because that is going to be it's going to allow us to use one method for the 4 different directions just by passing a different direction into the method. So in here we want to go and copy this, I believe, copy that and paste that in there. So in here, instead of having this forward here, we will go and replace it with our direction over there, because it's going to bring that in from our parameter over there. And then we don't really want a print statement here. Here we want to go and say return true, because what do I do? That needs to be return true. So if it does hit something, it's going to return true, which means you can't move into there, into the next position. And if it's false, we will just go and say return false, like that. Okay, so now let's go and say, what do you want to do? Okay, so we can, first of all, we can go and get rid of this. I'm going to cut that out because we need that. And then we'll get rid of that because we don't really need that. So now what we want to do is we're going to bring it into our update method, but we're going to pop it into our if statement here. And it's only going to get called when we go and press our up arrow. And later on, it's going to work for our down arrow, a left arrow, and a right arrow. So let's say if we have a move, we need to rename this because it doesn't make sense. If move cube, well, let's see something here quickly. Let's go and rename this to check for wall. We will replace that with check for wall, and then we need to replace it with our forward direction. So I'm going to paste that in there. We can type in forward in here. So that's going to put our forward direction into this method, and then it's going to figure out if we can move in a forward direction or not. So if we can move in a forward direction, then we want to go and move the cube, but as well as increase our count. And if we can't, then I think we can just leave it blank for now. So let's see. So this is wrong, first of all, because we need to have the other way. So first here we are saying if we check for a wall and it turns out to be there is a wall there, we're saying let's go and move into that wall. So that's not what we want. So let's go and cut that out. And in here we will say else, and then paste that in there. And then if we do check that there is a wall there and we find out that there is a wall, we don't want to move into the wall, and let's go and say return. So that's just gonna kick us out of this if statement, and then it won't allow us to move into that direction. So let's go and save that, and then I believe we can test it out and see what exactly happens. So hopefully this works. So here's our game. If we move backwards, you can see we can still move backwards, but if I try and move forward now that I'm at the maze by accident, let's just go back into the maze. You can actually see that, where am I going? You can see that it's working. So if I move forward, you can see that, I don't know if you can hear it, but I am pressing the up arrow and it's not going through our sphere here. Like I said earlier, if it's just going to try and detect if there is something in the way within that half unit length. But if we go to the other side and we go forward, we can see now that it is no longer, no matter how many times I actually tap on the up arrow, it's not going forward because there is that registering of the wall there. So now that that's done, we can simply go and copy this and just paste this in all of them, but we can change this to our back direction. This will be back direction, and that will be back. And then we just need to pop in a bracket over there, delete that line, save that, and then we can do the same thing for our left direction. Left direction, that's going to be left. And then just add another back bracket over there, tidy things up. And then lastly, over here we can do it again, and this is going to be from right direction, vector 3.right, and then check for wall in the right direction. And then just add another curly bracket, delete that line, and that should be enough to sort out our movement issue. So let's go and test this out. So if we press play, we should now see that we can move freely within our maze, and no matter how many times you press left, right, up and down, if there is a wall in the way, you can no longer move into that position. So that is working exactly how we wanted it to work, and you can see our move count is still working, but if we go and continuously press a key and we can't move into that direction, you can see that our move count no longer gets affected. So that is what we want. The only thing now that we have to do is try and figure out how to fix this issue where we can't collide with our trigger, or with our endpoint trigger. But maybe that's for another episode. So let's just try raycast. If we add a code on here, we can add in a layer mask. So let's go and see. I haven't really used layer masks, but I believe that's what we need to use. So let's go and say layer mask Unity. So let's see. So I will go and do some research into that, but I believe that is how we are going to allow our player to, or our cube, to move into our actual endpoint collision, not collision, trigger point, which is our sphere over here. We do have to change that on later on in the game, because we don't really want a sphere just floating around in the game. But that is going to be it for today's episode. So now that we've sorted out our movement of our cube, it's working quite nicely, to be fair. It's a lot better than I thought it was going to be, and it looks really good. We now have our movement count that we can display on our screen in the game. We have our moving cube moving around the inside of our maze perfectly fine. We probably need to make some more. Did we make some more levels? No, I made that in the first video that I recorded without audio. So next video we'll go and create another level just for fun, because who doesn't like more than one level? And then we will probably start adding in some different mechanics to the game. Probably have some raising platforms maybe to get you onto another level. Not another level, but another level in the game, in the current level that you're in, if that makes sense. So I'll explain it in the next episode, but that's pretty much it for today's episode. So if you enjoyed this video, go ahead and like the video, and if you're new to the channel, go ahead and subscribe if you want to. It does mean a lot, and it really helps. But yeah, that's it for today's video, and I hope you enjoyed it. So see you next time. Goodbye.